Hello and good morning to everyone. This is a presentation about the true beauty within chemistry, the noble gases. This is a presentation by Justin Reyes and I, Luis Reyes.
The periodic table is one of the most important creations ever made in the science world. There are currently 118 known elements that have been discovered, and there will definitely be more elements to be discovered in the future. Within the periodic table, one of the most important groups on the table are the noble gases. We have the elements of helium, neon, krypton, argon, xenon, and radon, and they can be found on the right side of the periodic table. These gases are colorless, tasteless, odorless, and non-flammable, and all gases have low temperature melting and boiling points. Each of these noble gases glow up a different color when electrically charged. Collectively, they make up about 1% of our planet's atmosphere. The first noble gas, helium, was discovered in 1868, and the group as a whole were initially called the inert gases and then changed to noble gases. Gases are known for their property to not react unless they are put in certain reactions. The reason this occurs is due to the full valence electron shells of these atoms, thus making noble gases extremely stable and unlikely to form chemical bonds because they have little tendency to gain or lose electrons. The first noble gas on our list is helium, and this element has an atomic number of 2. As we all know, the element of helium has a lot of relevancy due to balloons. A fun fact about balloons is that the element hydrogen was used in balloons until it was changed to helium because helium did not catch on fire. Helium was first discovered in 1868 during a solar eclipse by Jules Janssen when he found this element in an unknown yellow spectral line in the sun's chromosphere. This resource first became available in the market in 1928. However, helium is present in our planet's atmosphere at approximately 0.0005% by volume, meaning that there are 5 helium atoms per every million atoms of atmosphere, which is considered very rare. Many people only see helium as a use for changing your voice, but as a matter of fact, helium is used for many different other things that is helpful to the people of this planet.
Next up we have the element neon, which has the atomic number of 10. It was discovered in 1898 by the Scottish chemist Sir William Ramsay and the English chemist Morris M. Travers in their study of liquefied air. It is the 4th most abundant element in the universe, although it only makes up 0.0018% of the Earth's atmosphere. Neon is a highly inert element, and it is unable to form any known compounds. Neon gas is mostly used in advertising signs, high voltage indicators, and helium neon lasers. Liquid neon can also be used as a cryogenic refrigerant. The next noble gas we have on the list is argon, which has the atomic number 18. The people involved with the discovery of this element were the Scottish chemist Sir William Ramsay and the English chemist Lord Rayleigh. They discovered this element in 1894 through the isolation of elements from clean air. It makes up 0.93% of the Earth's atmosphere, and it is the 3rd most abundant gas in the universe. Argon is often used in light bulbs to prevent the corrosion of the hot filament from oxygen, and is also used to form inert atmospheres for any other processes involving the shielding of other gases. Argon only forms one known compound, which is argon fluorohydride.
Next, we have the element krypton with atomic number 36. In 1898, Sir William Ramsay discovered the element during a study of liquefied air and noticed liquid krypton after the air boiled away. This element was named after kryptos, the Greek word for hidden, because it was hidden behind another element. The discovery of krypton led to the discovery of flash photography and led to many creations of light bulbs, like the fluorescent light bulb, which saves a significant amount of energy. Krypton is present in the planet's atmosphere at a concentration of 0.00011%. Some uses of krypton are seen in the flash lamps of high-speed cameras, and it can also be mixed with argon and filled in energy-saving fluorescent light bulbs. In the food packaging industry, the noble gases is used in sterilization.
The next up on the list we have another elemental discovery from Sir William Ramsay and Morris M. Travers. Xenon was discovered on July 12, 1898, shortly after discovering the elements krypton and neon through the study of liquefied air. Xenon has the atomic number of 54, and it makes up about 0.000087% of the Earth's atmosphere. Xenon was once thought to be an inert gas before scientists discovered that xenon had the capability of forming compounds with other elements. Xenon is often used to power light sources. Lamps that use xenon tend to illuminate better than conventional lights. We see them in things such as photographic flash lamps, sunbed lamps, and even vehicle headlights. Our last element on the list is radon, which has the atomic number 86. It was discovered by the German chemist Friedrich Ernst Dorn in 1900 through the study of the decay chain of radium. We still obtain radon today through the decay of radium. Radon is a radioactive noble gas, and it makes up a very small percentage of the Earth's atmosphere. Radon is sometimes used in small amounts to treat some forms of cancer. Because of its radioactive nature, it will decay into more stable solid elements. Radon has a relatively short half-life, and its most stable isotope, radon-222, has a half-life of about 3.8 days. Radon is only known to form one compound, which would be radon fluoride.
Noble gases are of very importance in our everyday life, as we make conclusions about the other valence shell completion of other elements by knowing the noble gas configurations. As we have learned from our last unit, the help of the noble gases when writing the noble gas configuration is very essential. When using shorthand notation for an element or ion, we would all refer to one of the 6 noble gases and fill in the rest with the valence electrons. In society, krypton and xenon are used for commercial lighting applications. Krypton can be used for incandescent light bulbs and fluorescent lamps. Both are also employed in flashing stroboscopic lights that outline commercial airport runways. Helium's low density and inertness make it ideal for use in lighter-than-air craft such as balloons. Because of the element's very low boiling point, it has many applications in low-temperature research and technology. Divers breathe an artificial oxygen-helium mixture to prevent the formation of gas bubbles in the blood as they swim to the surface from great depths. Neon is well known for its use in neon signs. Glass tubes of any shape can be filled with neon. When an electrical charge is passed through the tube, an orange-red glow is emitted. As well as for argon, it is used to provide an inert atmosphere in welding and high temperature. And finally, for the last noble gas on the periodic table, radon can be used in the production of radium and is used to help treat one of the most abundant diseases in society, cancer. In conclusion, we would like to remind everyone that every group in the periodic table has their own important role in making society. But without the noble gases, we have a large part of our little sciencey hearts gone. But before we finish our presentation, let's play the Joe game real quick. A noble gas walks into a bar. The bartender says, "We don't serve your kind here." Everyone in the bar just stops and stares in awe. The noble gas has no reaction, but
That will conclude today's presentation. Thank you all for listening.